Well, good morning. I hope you can hear us this time. Francis Wilson, me. I do the weather in the morning on breakfast time. You've probably seen that occasionally. We're, of course, up at Queen's Tower here at Imperial. Lovely morning, dazzling sunshine, lovely blue sky. If you take it, let's look around, because it is quite a splendid view. Behind me to the west, there's a veil of cloud creeping in. And then we're looking further down towards South London now. You see the South Downs in the distance. You see the individual cumulus cloud, the morning cumulus beginning to puff up. And then there's the Crystal Palace transmitter in the far distance. I don't know if you can see that. And the Battersea Power Station a little bit nearer. Just looking at those individual cumulus clouds, from the fixed ground points, knowing how far between, say, two office blocks, they seem to be going around 20 miles an hour. The cloud level winds, essentially from the southwest or west. And the base seems to be about 3,000 feet, which is about a 5-degree angle it subtends with the ground. And then the top of the cloud is just a little bit of an angle on top of that. I should say about a fifth of the angle to the base. So from the base to the top of the cloud, about a fifth of the distance from the ground to the base. So we're talking about cumulus, base 3,000, tops 3,600, 700, growing as the sunshine becomes stronger. And they're fairly littered in the sky. As the sun gets stronger, of course, it causes stronger thermals, which are able to rise up to the condensation level, 3,000 feet, and then continue with more energy to greater heights, causing larger and larger clouds to form. So the question is, will the clouds grow individually high enough to give showers, individual showers? But if you look on the horizon behind me there, I don't know if you can make out, but there's a different tone to the sky. It goes sort of milky, whitey grey rather than blue. There is a sort of veil of very high-level cloud, high-level ice cloud, just sneaking in over the horizon. That indicates to me that there must be some stability aloft, obviously not in the lowest layers of the atmosphere, because we've got the cumulus, but above that I think there is some stability, and that will limit the depth of convection. So there must be a cap on these cumulus this afternoon. Would think they would grow up to 5,000 or 6,000 feet maybe, but not sufficiently deep enough to give showers. So we're talking about fair weather cumulus today, lots of bright, even dazzling at times, sunshine, but the lid coming across on the top to limit all that activity. In the distance that way, the horizon from a vantage point like this, 300 feet up, works out to be about 20 miles. It's 1.2 times the square root of the height in feet is the number of miles away the horizon is, with 300 feet, so it works about 20 miles. But of course the high-level cloud, the cirrus, is at about 30,000 feet typically above the ground, so that's sneaking over the horizon at a much greater distance away. And that horizon distance works out to be, if you do the triangles, about 200 miles. So if we think that the weather's moving at, say, 20 miles an hour-ish, and it's 200 miles away, we're talking about 10 hours' worth we probably can see across the country from this high vantage point. So by observation, and without going into anything else, not looking at any weather maps and so on, it's a fair weather cumulus day, bright sunshine, nice, but clouding over towards the end of the day. And of course the veil of high-level ice clouds is normally the forerunner to a weather depression, a rain system coming in from the Atlantic. The winds are from the west, so the weather is coming in from the Atlantic. So we're talking about probably rain maybe tomorrow. So it's, you know, this is all iffy and guessy, but that's what you can get from just standing here watching the sky. Perhaps we could now look further afield. The way to do that, and an obvious easy way to do, is get a satellite to view a large view and see if there's anything coming in and developing. We'll have a look at this morning's compilation from Meteosat. Meteosat's the weather satellite, about 22,000 miles out in space. And this is what it sees. Well, the striking feature is the split between the cloud and the clear at about 50 degrees north. You can see very cloudy in the sort of latitudes of Britain, but further south over the Med, once again, they're into their heat wave days. Temperatures up to 30, getting towards 100 F in some places. Greece, of course, you probably know, having a tremendous heat wave. We'll take a look at that same thing again, but this time a little closer in, see if we can pick out any detail and see how far away the banks of cloud are. coming in then from the Atlantic, and particularly from the southwest approaches, I think, that cloud is spilling in. As we go through the night and into the small hours, there's a definite hole in it, and that's currently over the southeast of England, you'll see there, before it just disappeared, with more cloud to come. Well, those things are made daily from Meteosat here at the satellite receiving station at Imperial College. Dr. Chris England here, who's with me, is someone behind all that who compiles it and sends it across the BBC, which I would then show you each morning. Of course, we are looking at the movement of clouds from a satellite during the night, so we can't really be looking at clouds, can we? Because there's no sunshine to highlight them. So, Chris, what exactly are we looking at from Meteosat?
Well, they are sort of clouds. Essentially, it's the infrared emission from the clouds and the land as well. Yeah. Because the clouds at different altitudes, you get different infrared emissions because they're colder as you go up, which means that the bright white bits are definitely clouds on there. The darker grey pieces may be low-level cloud, maybe fog, maybe the land surface. The particular problem with this, not so much at this time of year, but in the autumn, is fog, which, because it's the same temperature as the land, doesn't show up at all on the sequences. So we have to try and juggle the levels of what we show to give something that is roughly the cloud, or the cloud that's meaningful, in a sense, purely because it is, so it's not visible radiation, it's infrared, and it's not so distinct between the cloud and the land.
So we're looking at a thermal map, we're looking at blotches of cold and hot. You calibrate them to cloud or clear, but some weather systems you'll miss, as you say, like fog, because it's the same temperature as the underlying surface.
That's right.
Yeah. And how kind of close in can we look? What resolution have we looked? Can we see Can we see these individual cumulus clouds?
The actual single pixel size, it's the smallest bit you can see on the image, is 5 kilometres by about 8 kilometres over the UK. So these ones are a bit small. Big thunderstorms, that sort of thing, you can see as distinct blobs. But even so, they're only a few pixels across at a time, so they're blobs, but fairly small blobs on the image. This sort of thing just comes as sort of a grey, an average of the cloud and of the land underneath. Yeah. And you can do some things to show that, but it's not. You tend to get a grey sheet appear in the movies, or you get something with lots of holes and not really such an indication of the cloud amounts.
Yeah. Right. Well, you compile these images that are sent from Meteosat. They're sort of 1 an hour-ish, and string them all together to make a movie. Could you tell us how you do that? And I think we've got a little bit of a tape here that will probably highlight it, which we'll show you. Chris will then talk us through what's going on. What's going on here, Chris?
Okay, first we're starting off basically just an image of the world as taken by Meteosat. And that just shows you the area seen by the spacecraft. This is a better one. Midday. Africa, you can see it's a black lump in there with Arabia off to the side. The UK is at the top under all the grey gunge. It doesn't show up very well. So what we have to do is zoom up on a section of that, take a small slice at the top, and hopefully we'll be running a sequence of black and white images through the night whenever they get here, that will show you the basic development. So we saw before, but this is in the actual raw satellite data. It's being loaded up into sets of 4 here because of various technical reasons to do with the computer we manipulated on. You can see Spain there in the top right one particularly. There's a black lump, and Africa underneath that.
So each of these quadrants is an hour apart, is it?
That's correct, yes. And these are over the night. I guess much like the picture you saw before, but it's much harder to see the land and the sea as distinct from the cloud because the greys just tend to merge one into the other. So what we're doing here primarily is a test run to see that the images we've received are actually all correct. There have been no problems with the satellite actually acquiring the images and disseminating them to us.
And the land's in the same place on every image, so they've all got to be registered one on top of the other. We can't have the land moving around.
That's correct, yes, they have to be the same place. Otherwise it's dance. No, we've got more coming. It's going to run through these.
So how many images are you trying to collect and put together?
We've got 18 images.
So 18 hours worth of weather, and it ends at about sort of 7, 8 in the morning.
7 o'clock this morning.
So that's a good night's worth, yeah. Where are we now on the tape?
We should be running a sequence in black and white, which shows you the same features as we had before in the previous coloured movie, but again it's not so clear. And we ran it very quickly there, just flicking from one image to the next in the sequence. again, that's not the way we do it for the actual movies that we use. There, it's trying to slow it down, so you've got more time to talk over what's happening. It's a sort of slow development, and you can have time to point out the features as they develop. If we go back to the tape now, we should be seeing the processing that goes on. First we'll take one of those images, change the brightness and contrast to bring up the high-level clouds and separate the different cloud levels. We mix in a coloured surface map underneath that, and we can adjust the cloud amounts to make it a nice day if you want one, or otherwise.
So, well, in the latitude of Britain, there you said there's a lot of cloud over the latitudes of Britain, but there wasn't much cloud over Spain, was there? Now, that's slightly a function of the way you set this threshold, isn't it? Because presumably, with the perspective from Meteosat that's on the equator, looking up towards Britain sort of disappearing around the top of the globe, the clouds are all crowded together, and you get this kind of impression there's always a lot of cloud up there. But it's not possibly true all the time, is it?
It's not totally true. There is more, in fact. The biggest problem is that as you go south, everything warms up and the clouds warm up. So, I mean, a cloud at a fixed height in Spain is a warmer cloud than a cloud at the same height in the UK. Yeah. So when you do this chopping off, which is basically based on temperature, you tend to lose the clouds in Spain first, because they're essentially warmer, because the whole of the atmosphere is warmer there. The actual perspective thing doesn't matter too much, because when you think of the relative heights of the clouds to the separations, it works out that it really doesn't make much difference.
Okay. And is that tape finished now?
That's the end of the sequence. I mean, basically, we process all the images the way you've just seen.
Right.
And then just make a movie by fading one image up and the other one down sequentially through the sequence.
Yeah, so you put all those images together, stack them up on top of each other electronically, really, and flick through them, we get the movie effect. Okay. Right, that's from Meteosat, the meteorological satellite. There's a new meteorological satellite been launched recently. Is that going to provide any additional or better improved data?
No, unfortunately not. The one that was launched a couple of weeks ago now is basically a replacement for is a stand-in, a temporary thing. It's a refurbished prototype, effectively, because unfortunately the one we're using at the moment's run out of fuel. It needs fuel to keep on station. It's run out of that, so it's starting to drift away from where it should be. So they've launched another one as an interim, basically a stopgap measure, until they launch the first of an operational series. This has been a nominally experimental satellite, which again will have the same instruments, more or less the same instruments, and will not actually show any more information than we get from this one. There is a new project, talking 10, 15 years, for an enhanced spacecraft, which will show more detail, have images in different parts of the spectrum, to give more information on cloud types, and so you'll be able to do more to separate things like fog, perhaps, from the ground and different types of cloud by mixing different spectral regions of data in the imagery.
Right, okay. Well, what happens once we get that compilation each morning at the BBC is that we will then use it and extrapolate the motion that it shows to form what we call a predictive sequence, which is basically non-developmental, i.e. we're not able to spring up individual cumulus clouds on the weather movie, but what we can do is take an Atlantic weather system that is really there and just move it further in or out, whichever way it's going. In that way, show people, or gives people some idea of the timing of the movement of weather systems. The way we do that is a trade secret, but that's what we do. And for today, I would be looking at that compilation there and saying that it confirms the observation that it's going to be a nice day today, but breaking down this evening with rain tomorrow. That'd be a general gist of the forecast.